Vertical load, also known as gravity loads, are forces that act downward on the structure and to the ground. They are primarily caused by the weight of the structure itself and any objects it supports. There are two types of vertical loads. The first is dead loads. Dead loads are permanent and constant load. They include the weight of the structural elements themselves, such as beams, columns, floors, roof, walls, and any permanent features like plumbing, electrical system, and built-in equipment. The second is life load. These are variable loads that can change in magnitude and location. They include the weight of occupants, furniture, movable equipment, stored materials, and other non-permanent objects. Life load can also include environmental loads like snow and rain that accumulated on roof. So we move to the effect of the vertical loads. The first is compression. They compress the structural members like columns, wall, pushing them downwards. The second effect is bending. They cause bending in horizontal members like beams and slabs, which deflect downward. So we move the importance of the vertical load. The importance of vertical loads is accurately calculating and accounting vertical loads is crucial in structure design to ensure the stability. They must be able to support its own weight and any additional load without collapsing. Second is strength. Structure's member must be strong enough to resist the compression and bending force caused by vertical loads. The third is serviceability. The structure must not deflect or deform excessively under loads, which can cause discomfort or damage to finish. Engineers use building codes and standards to determine appropriate value for the dead and life load based on the type of structure, its location, and its intended use. They then perform the structural analysis to ensure that the structure can safely support this load. Lateral loads are forces that act horizontally on the structure parallel to the ground. They are crucial for structure engineers consider because they can significantly stress and instability if not properly accounted. Here's a breakdown for source of lateral loads. First is a wind. Wind exerts pressure on the structure, pushing and pulling. The force depends on wind speed, the building shape, and the surrounding environment. The second is earthquake. Ground shaking during earthquakes cause horizontal force on the structure. The intensity depends on the earthquake magnitude, soil condition, and the building characteristic. The third is earth pressure. Soil pushed horizontally against the retaining wall, basement wall, and buried structure. The pressure depends on the soil types, moisture, and depth. The fourth is fluid pressure. Structure submerged in liquids experience horizontal pressure. The pressure depends on the liquid's density and depth of submersion. We move to the effects of lateral loads. First is overturning. The structure can top over if the horizontal force are too strong. Second is sliding. The structure can slide horizontally if the friction and its base insufficient. The third is shear. Internal stress within the structural elements can cause them to deform or break. The fourth is torsion or twisting. These troop lateral loads can cause the structure to twist. For the additional information, there are methods to resist these lateral loads. First is shear walls. Shear walls, strong vertical walls designed to resist horizontal force. Second is brace frame. Brace frame can create a rigid framework to resist lateral loads. The third is moment frame. Rigid connection between beams and columns resist lateral loads through bending. The fourth is diaphragm. Horizontal elements like floor and roof transfer loads to the vertical resisting element.
Hello and Assalamualaikum. My name is Muhammad Azruzain bin Muhammad Zaini, and my student ID is 2024963767, and I'm from Group 5. So for my topic is I will explain about the beam, column, and girder. The three things that needs to be included is what is it, purpose of it, and the example of it. So we will start with the what is beam. So beam is a horizontal structural member designed to primarily resist bending loads. They are typically supported at their ends and carry loads along their length. So for the column, vertical structural members designed to primarily resist compressive loads. They transfer loads from beam slab to the foundation. And for the girders, large primary beams that support other beams and significant loads. They are typically deeper and stronger than the regular beams. So I will explain it at the last part of the slide for easy for the viewer to understand it. So the purpose of columns, beam, and girders. First, for the beam, it can support floor and roof loads, transfer loads to columns or walls. And for the columns, we can transfer loads from beam and slab to the foundation, provide vertical support. And the third one is girders, support multiple beams and heavy loads and span large distances. So we can see that beam, column, and girders are connect together. From beam, it will go to the columns, and it will go and beam also go to the girders. So they are need to be together to build a strong structure. So here are the example for beam, column, and for the girders. So for the beam, we can see that wooden beams in the residential house, concrete beams in the bridge, and for the columns, there are 3 points, which is concrete column in a high-rise building, steel columns in a bridge, and wooden posts supporting a porch. Porch means that like a car parking. And for the girders, you can see for the box girders in highway overpass and truss girders in the roof. So here are the example for the photo for the beam, column, and girders combined together. You can see the slab, column, and the primary beam, secondary beam, and the foundation. You will go from the above to the below. Below means is going to the foundation. Foundation is the strongest part of the structure. So before we go into the conclusion, I will explain a little bit easier for uh, viewer to understand what is beam, column, and girders in the easy way to explain it. So imagine building a giant Lego tower. The tall, sturdy Lego bricks are like a columns, holding up the whole structure, and for the beams are like the shorter bricks that connect the column and spread out the weight of the Lego pieces on top. For even bigger Lego creations, you might use extra long, right? Super strong girders to support heavier section. Just like in a real building, this part work together to keep everything standing strong, and it will avoid it and prevent it from the building collapse. So let's go to the conclusion. So by the understanding the distinctions between beam, column, and girders, engineer can design and construct safe and efficient structure for people to go inside the building without any dangers that might let the building to be collapsed or anything. Thank you.